So today's topic is potential energy. So do you have energy? So how do you know if you have energy? Does the ball standing at the top of a hill have energy? And does a moving ball have energy? And so these are all the types of questions that we should be asking ourselves throughout this lecture, and that we should be able to answer after we've gone through energy. So remember, energy is the ability to make things change, and it moves through the action of work. Remember, work is in joules, and joules is energy. So let's say you're pushing a piano up a ramp. Explain the transfer of energy in this situation. So when you push the piano up a ramp, some of the energy is transferred to the piano by doing work. This person is doing work because as you're moving the piano up, not only are you moving at a distance, you're applying a force. Remember, force times distance is work, so you're doing work here. But your energy also decreases by the amount of work done. So the energy of the piano increases by the same amount of work done. So whenever work is done, energy moves from the system doing the work to the system on which the work is being done. So, for example, in the previous picture where the man is pushing the piano up, the work being done there and the energy is moving, it's also moving from the man to the piano. Energy comes in many forms. Last year in chemistry, or when you took chemistry, we talked about nuclear, chemical, and thermal, and even some pressure energy. In physics, we deal a little bit more with mechanical, light, and electrical, even though it's all really related. It's all physical science. So mechanical energy is one of our main focuses, and this is the energy to do the position of something or the movement of something. Mechanical is moving energy, and so it can either be kinetic or potential. So although we're going to be talking about potential and kinetic, we're really talking about mechanical energy at different states. If you lifted a couch to move it and accidentally dropped it on your foot, what would happen? Yes, of course it would hurt. But why? What happened? Explain what happened in the sense that energy was transferred. Would it hurt more or less if the couch was raised higher when you dropped it on your foot? Why? Talk energy. Okay, so in these processes, when something is lifted off the ground, one, you're doing work, right? You're applying some type of force to lift it, and you're moving in a certain distance, and it can fall back down. And it exerts a force as it's falling down as well. So that exerting force while falling means doing work. When you lift an object higher, you increase its potential energy, so the higher we move, the more potential energy. And it has more ability to do work when it falls. So objects that have potential energy do not use the energy until they move. They have this stored energy as potential energy. So an object's potential energy comes from the gravity of Earth. So we could say that it has energy from a certain height is called gravitational potential energy, or GPE. The potential energy an object can release coming down is exactly the same as the work you must put in to move the object upward in the first place. Remember, energy is conserved. You cannot have more energy as it's falling than it did when you raised it. Energy can't come out of nowhere. So explain the transformation of the mechanical energy of the ice cream as it fell off of the cone. You can only do as much work as you have energy. And the energy you have is equal to the work done to create the energy in the first place, because work is energy and energy is work. So when we're talking about potential energy and we're doing our calculations, remember energy is in joules. Potential energy will be represented by a capital E, and sometimes it'll have a lower p here, or sometimes we'll just say potential energy like this, equals mass, which is in kilograms, G, which is the strength of gravity, 9.8. That's a constant, it'll always stay the same, and height is in meters. So the higher an object gets, the more potential energy it has, and this is exactly what this graph is showing. So let's say, for example, we have a 14 kilogram box, so that's mass. It is raised to a height of 4 meters, that's my height. What is the gravitational potential energy relative to the ground? So first of all, when we're doing with a problem like this, make sure you write down your variables first. So we have M is 14, H is 4, and a question mark to the potential energy. We don't know what that is, so let's calculate that. Okay, and don't forget also G, right? Because gravitational potential energy equals M times G times H, which here gives us 548.8 joules of energy.